So this is my project 1.7 submission, where I show that I was able to successfully import the EJML library, which allows me to use their simple matrix interface to calculate the inverse of a matrix, and show that I can use try and catch to catch an illegal argument exception, and also that I can write a function that throws an illegal arguments exception. This here is my code that multiplies two matrices of arbitrary size together. However, if the sizes of the matrices are not compatible, specifically the number of columns in the first matrices is not equal to the number of rows in the second matrix, then the program will throw a new illegal argument exception explaining what the matrix dimensions were and that they're not compatible for multiplication. I then declare a few matrices. A and B are filled with random data, or A, B, and C are all filled with random data, and then provided by this random. This is the functionality where they're filled with the random data, and then I attempt to multiply matrices A and B, which should be possible because, as you can see, the number of columns is indeed equal to the number of rows. And then we attempt to try to multiply B times A. However, these numbers do not match, therefore B times A should fail. And if you look, B times A does fail in the program output, where it tells me, if I can grab that, it tells me that there was an illegal argument exception, that the matrix dimensions 3 by 5 and 4 by 3 are not compatible for multiplication. Then, as a demonstration that I can use the simple matrix construct from EJML to invert a matrix, I take simple matrix sim A, which is a simple matrix of C right here, which is another matrix filled with random data, which I should actually probably print out, so I'll fix that real quick by simply taking a copy of my existing code to say A, and then I want to print out the matrix sim A using this handy function provided by EJML for printing a matrix. Now, if we run the code again, we can see that A is this matrix filled with random numbers each less than 10. It has 4 rows and 4 columns. And after EJML computes the invert function on this matrix, we get this matrix with 4 rows and 4 columns that should, in theory, provide the inverse.